Hello, everyone. I hope you're having a great day. We're going to start talking about factoring special products. When you're factoring special products, first we're going to look at multiplying so we can see what the special products are made up of. All right, so multiplying. Let's look at these two binomials that we're going to multiply together. These are actually called conjugate binomials. But let's just go ahead and see what happens. So I have 3x times 3x, so I have 9x squared, and then 3x times -5, so I have minus 15x, positive 5 times 3x, so I get plus 15x, and then a positive 5 times a -5, and I get minus 25. Now this time, what happens to my middle term? Make sure you look at that. They're opposites. So what do? They subtract out. And I'm left with 9x squared minus 25. All right, now let's look at my other special product. Hopefully remember that a binomial times a binomial is always going to be a trinomial. Well, a binomial squared when I'm talking about this particular one, not all binomials times binomials, but your binomial squared is always going to be a trinomial because number one, you can't distribute that square in there, so you want to write it twice. Then m times m is m squared, m times positive 8 plus 8m, and then 8 times m, so I get plus 8m again. And then I have a positive 8 times a positive 8, which is a positive 64. Here, my middle term repeats, or it doubles. Okay, so when it doubles, right, m squared plus 16m plus 64. All right, so we have our difference of squares here and our perfect square trinomial. So let's kind of look at that a little bit here. So it says perfect square. A perfect square has a coefficient that has an integer square root, 9, 25, 64. Those are perfect squares. And an exponent on the variable, they're even. Okay, so anytime you have an even exponent, that's going to be a perfect square. All right, so a perfect square trinomial. Do you always have to find the perfect square trinomial by using the pattern? You don't, because you can still factor it. But there are three questions that you can look at. Is it a trinomial? Are the first and last terms positive perfect squares? So that's what that positive PS means. So positive perfect squares. Is the middle term twice the product of the square roots, okay, of the first and third terms? So let's look at this. My first example that I have here, number one, I have 4n squared. Is that a positive perfect square? Yeah, it's 4 and it's n squared plus 25. Is that a positive perfect square? Yeah, it is. So then you say, okay, well, I think it's going to be a binomial squared. My sign is a positive. The square root of my first term. What is the square root of my first term? 2n. What is the square root of my last term? 5. It says, is the middle term 2 times the product of the square roots of the first and third terms. Sometimes I say first and last term. So 2 times 2n times 5. So multiplying this together, 2 times 2 is 4, times 5 is 20. Is my middle term 20n? Yes. So this is a binomial squared. So if you know the pattern, can you still go through the factoring, how to factor a trinomial? Absolutely. But when you see something like the second example B, you look at that first term, 64, because that's a big number, but 64p squared. Well, 64 is a perfect square. P squared is a perfect square. Then 9. Is 9 a perfect square? Yeah, 9 is a perfect square. So I think, that's when you say, I think it's going to be a binomial squared. My first term, 8p. My last term, 3. The sign of my middle term is the sign, or the sign of my binomial is whatever sign is in front of that middle term. So now I'm going to say, is the middle term twice the product? Okay, so we say 2 times the product of the square roots of the first and third terms. So I already have those right here. So 2 times 8p times 3. You're not taking the sign right here. You're just looking at, figuring that part out. So here I have 2 times 8 times 3, which is going to give me 48p. Is that my middle term? It is my middle term. So that's one way of factoring these perfect square trinomials. But again, it's a trinomial. Do we have other ways of factoring trinomials? Yes. When it comes to binomials are very specific. Anytime you're factoring a binomial, the only types of binomials that are factorable are difference of squares, which we're going to look at, sum of cubes, and difference of cubes. Anything else is not factorable. So it has to fit into a specific criteria. All right, so difference of squares. So think about that, difference of squares. In my first example, I'm going to look. Is subtraction happening? Yes. Are both terms perfect squares? 25m squared, 9 is perfect square. So then you say binomial times binomial with opposite operations. One's a plus, one's a minus. Excuse me. Square root the first term, 5m. It's the first term in both the binomials. Square root the last term, 3. It's the last term in both the binomials. So looking at one like number or B, we have to do a little bit more with B. So with B, I have binomial times binomial, perfect square, x squared plus minus 9 and 9. Now I have a special case now here. Here I'm looking at, here's a negative, so can I keep going? Is this a binomial? Do I have a perfect square minus a perfect square? Yes. So therefore, I do keep going here. This one is factorable. Binomial times binomial, opposite operations. Square root the first term, square root the last term. This one right here is not factorable. I cannot factor that one. So now I have x squared plus 9. So I'm going to close that. That's as far as I can go with that. All right, now I have the other binomial here that you're going to look at that is factorable. This is one where, once again, you have to memorize how that pattern is. So here's my pattern. The pattern is up here so that you can see it. And as I go through them, you'll hear me what I'm repeating. All right, so this time you have to know perfect cubes. I've listed the first few perfect cubes here. You can also in your calculator find out if something is a perfect cube. Just by taking your calculator and saying 5 raised to the third power. So you can look at and try your numbers if you're not sure if it's a perfect cube or not. All right, so but I do have them listed right here for you. And exponents this time are multiples of 3. So before, when we looked at even, it was multiples of 2. Now you're looking at, or excuse me, when they were perfect squares, there were even exponents. All right, so looking at my first example, is my first example, is it a binomial? Yes. Is subtraction happening? Yes. Are both terms perfect squares? No. I can tell by looking at this first term that it's not a perfect square. So therefore, I look at the next question then is, are they perfect cubes? Well, n to the third, 3 is divisible by 3. And then 125, we actually just looked at that. It's 5 cubed. All right. So we have what's called SOAP. So it's same sign, opposite sign, always positive. Okay. So the first one, the first sign in your binomial is going to be the same sign as this given binomial here. So that S is same. The O is opposite. And AP is always positive. All right, so that's how you do your binomial times your trinomial. So these are your patterns. You follow this pattern every single time. All right, perfect cube minus a perfect cube. So binomial times trinomial, same sign minus, opposite sign positive, and the last term is always positive. Now you're going to cube root the first term n and cube root my last term, which is 5. All right, so now you're going to use your binomial. Once you have that binomial, then you use it. All right, so here I'm going to write underneath square first term, square last term, product between. Okay, so that's what you'll hear me say. So square my first term. So n squared. Square my last term, 25. Product between. So the product between is 5n. You already took care of your signs, so there's no sign that you're using there. All right, so let's do the next one. I promise you it will get easier. Okay. So is subtraction happening for this binomial? No. So the next thing I look at is, are they cubes? Yes, they are cubes. So binomial times trinomial. Same sign, opposite sign, always positive. That's your SOAP. Same sign, opposite sign, always positive. I'm going to cube root my first term. Cube root the first term is 2x. Cube root the last term is 3. Now I'm going to use that. So remember, square the first term. So square 2x is 4x squared. Square my 3 is going to give me 9. Product between 2x times 3 is 6x. Okay, let's do it again. Binomial times binomial, same sign, opposite sign, always positive. Cube root the first term, b. Cube root the last term, 4. So if you're not sure, right, again, so let me show you this too. 64, we'll see this later on, raised to, I want to see if there's if it's a perfect cube. I don't want to raise it to the third power. I'm going to raise it to the 1 divided by 3 power. And that will tell me what my cube root is. So that's another hint. So 1/3 power is going to be, it's going to tell you what the cube root is. All right. So once I have that, now square my first term, square my last term, product between. One more time. Binomial times trinomial, same sign, opposite sign, always positive. Cube root the first term, 4a. Cube root the last term, 5b. Square the first term, 16a squared. Square the last term, 25b squared. Product between. So 4a times 5b, 20ab. So then let's just look at these real quick to say if they're factorable. Okay, so binomial. Is subtraction happening? Yes. Are both terms perfect squares? No. Are both terms perfect cubes? Yes. So therefore it's factorable. Next one. Binomial. Is subtraction happening? Yes. Are both terms perfect squares? No. Are both terms perfect cubes? No. So therefore not factorable. N squared plus 4. Is subtraction happening? No. Are both terms cubes? No. Then it's not factorable. A perfect square plus a perfect square is not a factorable binomial. That's not factorable. Because if you have n plus 2 squared, that's actually n squared plus 4n plus 4. Remember, a binomial squared is always a trinomial. So that binomial is not factorable. The next one. Is subtraction happening? Yes. Are both terms perfect squares? No. Are they perfect cubes? No, not factorable. Next one. Is subtraction happening? No. Are both terms perfect cubes? Yes, factorable. Next example. Is subtraction happening? Yes. Are both terms perfect squares? Yes, factorable. Okay. Here, greatest common factor. Yes, I have a greatest common factor, 2, n minus 2. So then I look at what's inside. Can I go any further? No, not in that binomial. So the only that right there is factorable because it has a greatest common factor. Next one. Is subtraction happening? No. Are both terms perfect squares? No. Are perfect cubes, excuse me, no. So therefore it's not factorable. So watch out for the greatest common factors. Those are factorable. All right, hope you guys have a great day and good luck on your homework.